welcome back to Math's Playground. Today we'll be doing some SAS similarity. So let's start with something simple. In the figure below on the left, we have AB by AC is equal to AD by AE, which is equal to 4 by 5. And clearly, angle BAD is equal to angle CAE. We wish to prove that triangle ABD is similar to triangle ACE. Note that we cannot assume that BD is parallel to CE. We have to prove it. Okay, so we don't really know how to start because if we don't have any parallel lines, then we can't find any same angles or anything like that. And side angle side similarity is where if you take two sides of a triangle and then take the same two sides, same two corresponding sides of another triangle, and the ratio is the same, and they have a common angle in between the two sides, that means the two triangles are similar by SAS similarity. So since we seem really stuck, we're going to make the same triangle, but we're going to take a point X on line AE as shown on the right, so that we can say that BX is parallel to CE. Now all we have to do is prove that that X is the same point as D. Okay, so let's start off by finding some similarities. So notice that taking BX is parallel to CE is not the same as taking BD is parallel to CE because we're trying to prove that X is the same point as D. So let's start with some similarities. Since BX is parallel to CE, we know that angle ABX and angle ACE are the same, and angle AXB and angle AEC are also the same. Okay, then we have triangle ABX is not parallel, is similar to triangle, so triangle ABX is similar to triangle ACE. Okay, then we have the, so now we've proved that these two triangles are similar. Now all we have to do really is prove that X is the same point as D. So how do we do this? Let's start with some side ratios, so we can use them for the to prove that X is the same point as D. So let's start with AX by AE. Then that must be equal to AB by AC, because again, triangle ABX is similar to triangle ACE. So then, and we know that AB is 8 and AC is 10. So we know that this is equal to 4 by 5. Okay. So now, so then AX is equal to 4/5 of AE, right? So then we have 4/5 of AE, which is the same length because we have the same triangle, but we don't know what's 12, if it's 12 and 3 or 5 and 10, but we do know that AE is 15. So we have AX is equal to 4/5 of AE, which is 12. Then AX is the same length as AD, which proves that D is the same point as X. And then we have ABD is similar to ACE. We don't always have to do it with one triangle. Sometimes you can add two. Okay, next question. Given AC is equal to 4, CD is equal to 5, and AB is equal to 6, find BC if the perimeter of triangle BCD is 20. All right, so let's say with a few side ratios so we can find some similar triangles. So if we do AC by AB, then we have 4 by 6, which is equal to 2 by 3. And then if we do no, then let's use the corresponding sides. Then we have AB by AD is equal to 6 by 9, which is equal to 2 by 3. Since the since the corresponding sides of triangle ABD are 3 by 2 the corresponding sides of triangle ACB, then we can say that BD is equal to 3 by 2 BC, because we're trying to find BC. So now we know that the perimeter is 20, right? So now we can substitute, since BC plus CD plus DB is equal to 20. We can substitute and say that BC plus CD plus 3 BC by 2 is equal to 20, which gives us that BC is equal to 6. Let's just check to make sure. So we have 6 plus, we know that CD is 5, plus 3 BC by 2 would be 9. So 6 plus 5 plus 9 is 20. Okay, let's do some challenge problems now. Okay, so now let's start on some challenge problems. So let's find DE in the figure below. This isn't much of a challenge problem. We've just got to find some side ratios and apply. So if we start with AB by AC, so we have AB by AC is equal to 3 by 4.5, which is also 1 by 1.5, which instead of using a decimal, we can write as 2 by 3. Now let's do AD by AE. So AD by AE is equal to 5 by 7.5, which is 2 by 3 again. So we can use this to find DE. So we know that BC is 6. So we have 6 by DE is equal to 2 by 3. So we have 2DE is equal to 18, which gives us that DE is equal to 9. Well, that was pretty easy. Not much of a challenge problem, is it? Okay, next challenge question. In the figure below, M is the midpoint of line EH and FG. E and F are midpoints of IM and MJ. Proves that line IJ is parallel to line GH. Okay, we could do that if we can prove that all of these angles of triangle IMJ are the same as all of the angles in GMH. And we can do that by proving that these two triangles are similar. Okay, since we don't have any side ratios to start off with, we can make some because it does give us some midpoints. So we know that I m is equal to 2em, and I E is equal to EM. And we also know that JF is equal to JF is equal to FM. We know that JM. We know that JM. We know that JM is equal to FM. We know that IM is equal to MA. We also know that EM is equal to H. And we know that M is equal to G. And last one, we know that JM is equal to G. Okay. So now that we have all of these side ratios, we know that I by H is equal to 2 by 1. We also know that JM by MG is also equal to 2 by 1, which proves that these two triangles are similar. And from before, we do also know, because of this X right here, I, H, and J, G, that angle IMJ and angle GMH are the same. And now, since we know that the two triangles are similar, we have all of these are all of these angles are the same, which gives us that IJ is parallel to GH. Woohoo! Well, that was more of a challenge question than before. Okay, last question of the day. Show that if WZ squared is equal to WX times WY in the diagram below, then angle WZX is equal to angle WYZ. Okay, Again, we don't have any side ratios, but we won't need them because see, the equation that they gave us, that should be true, is in the format a squared is equal to b times c. So if we wanted to write this in side ratios so that we can get some similar triangles, then we can write this as b by a is equal to a by c. Then we can cross multiply and then we would end up with this original equation. So let's use the same thing for the equation that we're using in this question. So we would have w x by w z is equal to w z by w y. Okay, and then we can cross multiply, blah, blah, blah. We'd end up with this original equation. And then we have that, then we know that WSZ is similar to WZY. So then, obviously, if you line up the corresponding sides, then we would have angle WYZ is equal to angle WZX. That isn't much of a challenge question either. See you next time!